Hello and welcome back. We'll finish up section 10.4 in this video, and we'll go through how to use some data in StatCrunch to find regression equations. And we'll find a few, and we will want to look at it to try to see which one is going to be the best regression equation to try to predict nicotine in a cigarette. We'll be given information about the nicotine content, the amount of tar, and the amount of carbon monoxide in the cigarette. So we see here, I've opened up StatCrunch, and I have a column for the amount of tar in a cigarette, the amount of nicotine, and the amount of carbon monoxide. And they're paired, so we can run some multiple regression here. So we'll come to stat. We go down to regression, and we have multiple linear regression. We have more than just one predictor and one response. So we use multiple linear regression. So let's look at looking at the linear regression for, we want to predict nicotine. So nicotine is going to be our y variable, and the two that we'll use to predict it, the predictor variables themselves, are the tar and the carbon monoxide. The rest of this I'm not going to affect in any way, and we will simply compute. So we get this pretty big table, and we'll go through where some things are. So it lists the dependent variable as nicotine. So nicotine will depend on the independent variables of tar and carbon monoxide. And then it gives us our equation. The amount of nicotine is going to be 0.21 plus 0.09 times the amount of tar minus 0.036 times the amount of carbon monoxide. So this is the equation that they give us. And I'm going to skip the parameter estimates and look at the analysis of the regression model. It gives us the p-value right here. So this is going to be less than 0.0001. So that's pretty small. Low p-value is good. This means that we can expect this equation to be accurate, this analysis to be accurate. Way down at the bottom, it gives us a summary of fit, to say the goodness of fit. And the important line is the r squared, and in particular the adjusted r squared. And that's going to be 0.894. So that is pretty high. It's pretty close to 1. So this is good. I'm going to shrink this down, and we'll leave this up here and down here. But maybe, just maybe, it's better to try to predict nicotine only using tar or only using carbon monoxide. So let's run this multiple regression again, but we'll only use one or the other. So let's come down to regression, again to multiple regression. The response variable is still nicotine, and now let's say that our predictor is only tar. So we will compute, and it gives us all of our statistics again. So again, the dependent variable is nicotine. Now the independent variable, the predictor, is only tar. So we get a slightly different equation. We come down and we see in the analysis that the p-value is still very small. So we would expect this to be fairly accurate. But the goodness of fit is now going to be 0.769 as opposed to 0.984. So that's almost a difference, going from 0.76 to 0.89. That's a pretty significant jump. So using both variables seems better than using just tar for the moment. And again, I'll just leave this there for now. And let's do one more regression. Again, multiple linear regression. And this time, I'm going to try to predict nicotine using only the predictor, carbon monoxide. And let's see how this does. Again, the dependent variable is nicotine, so this is what depends on the carbon monoxide. It gives us our equation. The p-value now is going to be 0.0054. Before, it was less than 0.0001. So that's a pretty high p-value when you compare it. So this is already looking pretty bad. And then when you come down to the r squared, this is going to be rounds to 0.26, which is much, much worse than the other two. So in this case, when we are looking at the difference between using one variable or using both variables, we can see that the adjusted r squared for using both variables is much, much higher than the other two, and the p-value, even though it's approximately the same as the p-value of one of them, is still very small, and it's much smaller than one of them. So the winner is going to be the multiple linear regression using all three, using both of the predictors as opposed to using only one of them. So if we were to write our equation down, let's just round this to say three decimal points. This will be the nicotine. It's going to be equal to 0.213 plus 0.093 times the tar times the amount of tar. I'll just use N for nicotine, T for tar, and then the last one is going to be negative, so we're actually going to subtract 0.036 times the carbon monoxide. The carbon monoxide. So here is the best regression equation when trying to predict the amount of nicotine in a cigarette. We do want to take into account both the amount of tar and the carbon dioxide. Using both of them is slightly better than using one individually. And there it is. This is the equation that we've used. And then if you were to give me the amount of tar in a cigarette and the amount of carbon dioxide, we could plug it in and use that to predict how much nicotine we would expect to be there. The very last thing that I'll mention, which is both useful and just comes right at the end of the section, are dummy variables. And normally, when we are thinking about regression, we want to consider quantitative data. If we are looking at the amount of nicotine in something and the amount of tar and the amount of carbon monoxide, these are all amounts that we can measure. But maybe we want to see how, say, the difference in height between being male and being female. So there isn't a way to sort of measure and assign a number to being male or being female, or say like resale value of cars. And we want to take into account whether the car is, let's say, white or not white. Here, what we can do is we can use what's called a dummy variable. And a dummy variable will take non-quantitative data and assign numbers to it. Specifically, with a dummy variable, this means that you have two choices of failure or success, kind of like the binomial distribution. And we'll just give a 0 to a failure and a 1 to a success. So this doesn't sort of take anything into account in terms of what the two choices are, but we're just going to assign a 0 to one and a 1 to the other one. And this helps distinguish between the two choices in a quantitative way, and it actually works quite well. So depending on the situation, maybe we would assign a 0 to male and 1 to female, and let's say that we're looking at predicting height. It might end up being that when a 1 is assigned to a female, it'll have a negative coefficient because women are going to be, on average, a little bit shorter than men. So a dummy variable will just assign zeros and ones to things that wouldn't normally be quantitative data. And this will come up in one or two of the homework questions. And that will end our semester.